These are all the equations you need for work in physics. Let's start with the basic definition for work, which says that work is done when a force causes displacement on an object. So in one dimension, we're going to have our equation W equals Fd. W stands for work, which is measured in joules. That's the amount of energy. Force is in newtons, and D is the displacement in meters. So if you're pushing a box horizontally with the force of 20 newtons over a displacement of 5 meters, and we want to calculate the work done, we just multiply the force, which is 20 newtons, times the displacement, which again is 5 newtons, and then we calculate the work done is 100 joules. Now we're going to use this formula for work when force is applied at an angle. That's going to be F d times cosine of theta. And so when multiple forces act on an object, we have to take the sum of all the works to get the net work. Get it? Net work. Okay, and so to do that, we have to basically sum up all the forces and then multiply it by that distance that it's acting on. Okay, so this is going to be common in forces like friction and normal force or tension, where you have multiple forces acting on an object. Now we can generalize this further and calculate the work done by a variable force, namely by summing up all the differential force terms and using this integral expression here. So work is defined as the integral of the force times displacement there. Okay, so this is going to be useful for springs, drag forces, or anything that has a variable force there. And then we also have to talk about kinetic energy, which is defined as the energy due to motion of an object, which is defined as Ke equals 1/2 times mv squared. So v is actually going to be the speed of an object. And there's a beautiful theorem that relates these two together. The net work on a system is defined as the change in kinetic energy, where the change in kinetic energy is the final minus the initial kinetic energy. So this means that the work done on an object changes its kinetic energy. Last but not least, we can't talk about energy and work without talking about the conservation of energy, which says that energy cannot be created or destroyed, only transformed from one form to another. And so this is the principle of the conservation of mechanical energy, where we sum the total energy initially, namely the kinetic energy initially plus the potential energy, and set it equal to the final kinetic energy plus the final potential energy. So in summary, these are all the equations you're going to need for work and energy. My name is Andrew Sanchez, and I have a PhD in chemical engineering. I offer tutoring for physics, chemistry, and math. If you want access to notes and resources just like this, a community of STEM lovers and engineers, or access to exclusive tutoring, comment the word work and I'll send you the link.